Good evening. This is 6.6, solving inequalities with absolute value. So yesterday we talked about solving equations with absolute value, and tonight we're going to talk about inequalities. So let's take a look at our first example here. Taking a look at this, we have the absolute value of x is less than 5. Well, remember yesterday, if we had the absolute value of x equaled 5, that would mean that x could either be 5 or x could be negative 5. So what that tells me is that here, there's probably two separate solutions. So if the absolute value of x is less than 5, we can go ahead and pretty much figure out that that means that x could be less than 5. Well, if x was less than 5, that would be fine. 2 would work, 3 would work, but let's take a look at negative 6. If x was negative 6, that would mean the absolute value of negative 6, which is 6, would be less than 5. And that is not the case. Therefore, x has to also be greater than negative 5. So x has to fall between these 2 points without touching those 2 points in order to satisfy this inequality. Because every number that lies between 5 and negative 5, not including 5 and negative 5, is a solution to our inequality. Because any number between 5 and negative 5 plugged into x will give you a value less than 5. So basically, what we can figure out is that anytime you have an absolute value of a variable less than a number, such as this, that means that x could either be less than that number or x could be greater than the negative version. And it would look like this when you graph it. So if we took a look at this equation or inequality here, I'm going to go ahead and set this up with two separate inequalities. I'll have t plus 5 is less than 9, because that would be true. If t plus 5 was less than 9, then that would be a true inequality. I'm also going to say t plus 5 is greater than negative 9, because if it was greater than negative 9, it would also fit the inequality. So I'll solve this just like I've solved inequalities in the past, and I'll find out that t could be less than 4, and here t could also be greater than negative 13. So when I graph that, I'll have 0, 4, negative 13. We know we have open circles because there's no equal sign here. And everything less than 4 goes this way, and everything greater than negative 13 goes this way. Therefore, the graph of our solution is like this. And we can say that for all t lies between negative 13 and 4. So you might be thinking, okay, I got it, so let me try this problem. But if you were to set it up like this, you would be wrong. And the reason is because this is telling me that the absolute value of whatever this is, we'll call it n, is less than negative 1. But what is absolute value doing? It measures distance. Distance from 0. Can distance be less than negative 1? No. Therefore, the answer is no solution. So go ahead and try these two examples on your own. So for this next example, we see that the absolute value of x is greater than 5. In other words, the distance from 0 has to be more than 5. Therefore, x could either be greater than 5, like 6, 7, or 8, whatever, or x could be less than negative 5, because if x was less than negative 5 and we plugged it in, say negative 10, 10 would be the absolute value, which is indeed greater than 5, therefore it works. So our graph will look like this, which is an OR situation. And basically, it's the exact same steps, whether it's a less than or a greater than sign. The difference is when it's a greater than sign, it's going to be an OR statement. Whereas when it's a less than sign, it'll be an AND statement. Let me show you. So, taking a look at our next example, my setup will be 2x plus 8 is greater than or equal to 6, or 2x plus 8 is less than or equal to negative 6. Because if this was some number n greater than or equal to 6, then that would mean that n could be greater than or equal to 6, or n could be less than or equal to negative 6. So, if I figured this out, I would find that 2x is greater than or equal to negative 2, which would just mean that x is greater than or equal to negative 1. And over here, I'll find out that 2x is less than or equal to negative 14, and x is less than or equal to negative 7. So if I wanted to graph that, I would have 0, negative 7, negative 1. And x being greater than or equal to negative 1 will go that way. And x being less than or equal to negative 7 will go that way. And the way that we would write our solution is exactly the same as how we wrote it before. So you get the the set of x, where x could be greater than or equal to negative 1, or x could be less than or equal to negative 7. Guess what that is? If you guess the secret thing, you might just be right. So, let's take a look at this one. 2y minus 1 is greater than or equal to negative 4. I hope you all caught that and said to yourself, hang on, you can't fool me twice. You can't have a negative number being greater than or equal to an absolute value. Nope, no solution is correct. However, had it said 2y minus 1 is greater than or equal to 0, that would have been fine. Because it's true. This could be greater than or equal to, it could be greater than negative 4, but it would actually have to be greater than 0. So go ahead and give these two a try. So in summary, if you have the absolute value of x being equal to a number, then x could be either a positive or a negative version of this answer here. If x, the absolute value of x was a less than n, that would mean that x could be less than n and it would have to be greater than negative n. And your solution for that would look like, right? And for this last one, if you have the absolute value of x is greater than n, then that would mean x would be greater than n or x would be less than negative n. So that would look like, except not all squished off to the side here. And that's what your solution would look like. Your graph of this one would also look like this. You'd have some 0, you'd have an n, you'd have a negative n, and one would be pointing that way, one would be pointing that way. If you had a less than situation, it would look like this. You'd have a 0, you'd have your n, you'd have your negative n, and they would be connected because everything in between would hold true. I hope that made sense. I will, again, not be grading for accuracy in the examples, but I will be checking to make sure that you are understanding everything properly. I will have 6.7 posted as soon as possible, and you all have a great weekend. See you Monday.